Hey everyone, so in the previous video we have been talking about the addition reactions. We did talk about the fact that alkenes give the addition reaction. We know that there is an addition of hydrogen, and there's another addition, that is the addition of halogen. In today's video we're going to be talking about the addition of steam. So right now, after coming along the way of addition of halogens, right now we're going to be talking about the addition of steam. So let's write the heading for that. We're talking about the addition reactions for steam. Addition of steam. Why am I calling it steam and not water? We'll see really shortly. Obviously we are very clear about the fact that is the vapors of water. So when we talk about alkenes, for example, I'm taking another alkene over here. By this time you guys would know that I am drawing a structure of butene. These are the hydrogens of the butene molecule. When you make sure that steam is being added over here, for example, steam is being added over here, you have remembered the fact that there is no change in the overall structure. The overall structure remains the same. I'm just copying the entire overall structure. The only thing that changes is that the double bond goes away. Your double bond goes away. You had a double bond over here, but now you don't have it. So the double bond has gone now. You had two carbon atoms which had the carbon-carbon double bond. I'm highlighting them. These were the two carbon atoms which had the carbon-carbon double bond, and now it is gone. You get two things added on these carbons. One carbon gets H atom, which is the hydrogen atom. Another gets OH group, which means hydroxyl group. OH is equals to hydroxyl group. So you add hydroxyl group, oxygen atom along with the hydrogen atom. So in the entire molecule, the only thing which is new is the OH group. You add OH group over here. Let's try another structure over here. For example, you have a branched compound. Let's say that this is a branched, for example, over here, let's make a branch out of here. We have our hydrogens right over here. These are the hydrogen atoms. Each carbon gets 4 bonds. This is a branch. And one over here, two over here. When you add steam into this compound, you make sure the entire structure remains the same, only the carbon-carbon double bond goes away. So you draw the same structure again. 1, 2, 3, 4 carbons and the fifth one. There's a branch right over here. All the hydrogens at the same place. Your hydrogens are right over here. This over here. There's one over here, one over here, one on the top, and the branch gets its own hydrogens. You had a carbon-carbon double bond on carbon number 1 and 2. These, I'm going to move this a little on top, and I'll make it a little smaller. I'll make it over here. Now we know that these carbon atoms had a carbon-carbon double bond. One of them gets the H because of the steam, because steam is actually water. It's a combination of H and OH. So one carbon gets the H from the water, another gets the OH. It is totally okay in which direction you are making your hydrogen and the hydroxyl group. It is totally definitely okay. You don't have to worry about that, but it has to be on these two carbons. The double bond goes away and you get H atom along with the OH group. The catalyst required for the addition of steam is actually phosphoric acid, which is H3PO4 is the catalyst. It speeds up the reaction and the temperature should be 300 degrees Celsius. So you need phosphoric acid as a catalyst and you need 300 degrees Celsius temperature. When you add OH group on the alkene molecule, it becomes alcohol. So remember the fact, guys, when you have an alkene, for example, in the beginning we had a butene. This was a butene. It was but because it had 4 carbons. It was ene because they had carbon-carbon double bond. It was a butene. But by the end, what you get is butanol. But because again it has 4 carbon atoms, but ol because it has OH group on it. Similarly, we can see over here, if I can use some other color, you can see this overall structure. I have 6 carbon atoms, so it was actually isohexene. This was actually isohexene. Hex because it has 6 carbon atoms, ene because it had a carbon-carbon double bond. But by the end of the reaction, it becomes hexanol. It becomes hexanol. It is still iso. It's still a branched compound. You can see there is a branch over here. It was a straight chain compound and a branch, straight chain and a branch. So you can know that it's isohexanol. Hexane means 6 carbon atoms and ol means OH group, which means alcohol. So now we have one idea very clear, that when alkenes go for the addition of steam, when they go for addition of steam, which means H2O in the gaseous state, you can write steam, you can write H2OG, in the presence of phosphoric acid catalyst and 300 degrees Celsius temperature, you get alcohol. You get a alcohol molecule. In the beginning you had a carbon-carbon double bond. The carbon-carbon double bond goes away and you get OH group, because water supplies H atom and OH. So from each water you get H group and OH group. Similarly, you did the same thing over here, H and OH on the double bonded carbons, on the carbons which had a double bond. Let's practice the formula. For example, if you had propene, you would make the addition of steam. So I'm writing the formula, the propene was C3H6. If you add steam in it, which is the addition of steam, what do you get? What you get is the same number of carbon, C3, but you get another H and OH. So you get H and OH. Water is a combination of H and OH. And one carbon gets the H, another gets the OH. So you can write it like this. Okay, you increase the number of hydrogen, you make it 7 because one H is coming, and then you can write the OH because OH is also coming. So you can increase a hydrogen and then you can write OH, and now it becomes an alcohol, which is a propanol. Similarly, let's try another example. If you had a butene, and if you were to do the same addition reaction over here, for example like this, you had a butene molecule which had C4H8, and you were doing again the addition of steam. What happens is that you make sure the number of carbon remains the same, C4, but again steam means H and OH, so it becomes H9 because you are adding a hydrogen, and then you write another OH because you're also adding OH. One carbon gets the H, another gets the OH. So right now you make a butanol molecule. It's an alcohol. Similarly, you can do the same stuff with other alkenes as well. Every time, let's use some other color for that. Every time the catalyst would be the same, phosphoric acid H3PO4 and 300 degree temperature. Phosphoric acid as a catalyst and 300 degrees Celsius of temperature. So in today's video we did look at the fact that addition of steam is done on alkenes. The carbon-carbon double bond goes away. One carbon gets the hydrogen atom, the other gets the OH atom. And it has to be the same carbons which had the double bond. While writing the formula, you write H on one carbon and OH on the other. So the formula gets one H and one OH, and you make alcohols out of those. Alcohols have their own homologacies that we will be talking about in the coming videos. Stay tuned, guys.